All right, class, welcome. We have topic 1-1, solving equations and inequalities. Now, I do realize this is a geometry class, and typically whenever you think about geometry, you're thinking of different kinds of shapes. You have pyramids, cubes, cones. We'll deal with some nets. Other type of figures that don't really pertain to equations or inequalities. However, I do realize, hey, you did have a summer break. Some of that knowledge could be forgotten, or maybe you just need a recap. So our topic 1-1, we will be dealing with solving equations and inequalities. We're going to hit some key points to this that I want us to focus on. We're going to focus on steps. We're going to be balancing the equations using the steps. We're going to use check steps. And, the major thing that you need to take out of this is the steps itself, no matter what level of math that you're at, be it Algebra 1, Geometry, Algebra 2, Pre-Cal, the list goes on and on. You need to really focus on the steps, and no matter what numbers, what variables that you're given, your steps will remain the same for any given problem type. And so that's what we really need to take out of this today. We'll be focusing on a few things. And if you'll have your notes ready to go, we will begin. All right, if you'll first look at our first problem, it gives us a problem that tells us to solve. Gives us x plus 5 equals 21. So I'm going to go over here and I'm going to write x plus 5 equals 21. Now, in solving any of these inequalities, we're going to work on balancing. We're going to leave this equal sign where it's at. A good habit to get into to learn, work with these. We're going to draw a straight line down through this. We're going to keep the equal sign on this all the way through. Now, one of your first steps, you're going to find the variable. We want to make sure we get the variable by itself in this case. A variable is our x. And in order to get it by itself, we have to get rid of this positive 5 that's on this side. Now, if we have plus 5, obviously the next thing that you're going to do is you're going to subtract 5. So we've got this minus 5. What you do to one side of this equation, we're going to do to the other side, minus 5. Now, whenever you do this, these two will cancel out. You'll be left with an x equals 21 minus 5, positive 21 minus 5. We do the math on that. Will leave us with 16. So, now that leaves us with a solved. The solution right here, x equals 16. Looks like it's solved. Now, like I said before, here's our steps. This will be step 1. This will end up our step 2, actually doing the arithmetic. But now, we've got a solution. We're going to check that solution. As it comes later on, it'll be pivotal that you do these check steps, because you'll find some solutions, especially if you get into some quadratics. One solution might work while the other does not. You cannot include both of those. So check steps, very important. Good habit to get into. Anywhere that we see, I'm going to go over here and grab another color real fast. Anywhere that we see an x in our original equation, we're going to substitute in a 16. So, my original equation, x plus 5 equals 21. Substitute in. That is a big key word. I think it's part of the language that you really need to learn. We're going to substitute 16 right in here for the x. So now, substituting in 16 plus 5 equals 21. Draw my line. Do the arithmetic here. You're going to get 21 equals 21. That checked out. Step 1 is complete. Alright, now let's look at, problem 1 is complete. Let's look at problem number 2. It tells us, go down here, get my original color, get it back. Alright, it tells us that layer up here. Alright, second layer here, it's going to tell us solve. It's got 32 minus r equals 16. 32 minus an r equals 16. Draw my line, find my variable. What variable do we have in this? We've got an r. In this case, it's going to be a negative r. We have a positive 32 over here. If you need to draw a positive, that's fine. Positive 32. In order to begin solving this, subtract 32. Subtract 32. It's going to leave us with a negative r equals. Now, we have a positive 16, and we have a negative 32. In order to do this, a simple way to look at it is subtract the smallest number from the biggest. So you would have 32 minus 16. It's going to leave you 16. Now we're going to come back and we're going to look. The greater number, which is a 32, in terms of the actual number, has a negative sign to it, so we're going to keep that negative sign. So it equals negative 16. Now, any solution that we have cannot be left with a negative with the variable. Therefore, we now have to get rid of that. How do you get rid of a negative sign if it is left over there? Well, what you do to one side, you have to do to the other, but we're going to multiply both sides by a negative 1. We're going to multiply over here. Put the little dot. If it's in parentheses, you should know that you're going to multiply. We're going to multiply both sides by negative 1. That will leave us r equals 16. Alright, so we've got our steps. We followed our steps through it. Now comes the check step. We have 32 minus 16 equals 16. There's my line. Do the arithmetic here. It gives you 16 equals 16. Checks out. Alright. Moving on fairly quickly. We're going to look here. We've got a fraction problem. 3 gives us 1/4, 1/4 times n equals 12. 1/4 n equals 12. When these two are together, same as multiplying. Now, we can rewrite this. And an easy way of looking at that, let's take something that y'all probably already know without a variable. Just say 1/4 times 3. In order to do this, we put 3 over 1. Anything that we have here, if we're going to multiply, we're going to put it over 1, multiply straight across, which would give us, in this case, 3 over 4. So we're going to look at this right here. We're going to rewrite this. It really becomes a very efficient way of doing it. We're going to multiply 1 times our n. We'll put our n over 1. Do the multiplication. 1n divided by 4 equals 12. Now you're looking at something that it's just a little bit less intimidating than looking at this fraction over here by itself. Now we know that we've got this 1 times n divided by 4 equals 12. Now we can do the opposite steps. The opposite of dividing by 4, let me draw my line over here that I almost forgot. Opposite of dividing by 4 is multiplying by 4, which would be 4 over 1. Multiply by 4 on both sides. 4's will cross out right here. We'll be left with something over 1, which will be 1n or n equals 12 times 4, or 48. Now, there we go. It looks like we've got it solved. Let's test it out. Now you can use your original problem, but this is just it's the original written down a different way. So I'm going to actually use this. I'm going to use 1. Now is our n, so I'm going to put in a 48. We're multiplying, so that's why I'm putting the parentheses. Over 4 equals 12. Draw my line again. 1 times 48. 48 over 4 equals 12. 48 divided by 4 is 12 equals 12. And that checks out. Alright, problem 4. We've got another fraction involved with an extra step. 7 over 3 times an x minus 2 equals negative 37. Alright, first step, I'm going to go ahead and rewrite this. I'm going to draw my line. And I do realize those lines are not the straightest in the world, but I'm going to rewrite 7x over 3 minus 2 equals negative 37. Alright, first step. We've got our multiplication, division. We're not going to look at dealing with that whenever we're working through these problems, backwards. We're going to take this and we're going to do our addition, subtraction first. So, here's what we have to take care of. In order to remove that, we have a subtracting 2, so we're going to add 2 to both sides, plus 2 to both sides. Leave us 7x over 3 equals. Now, here we go. We're looking at two totally opposite signs. Go ahead and subtract. 37 minus 2 is going to give you 35. Keep the sign of the larger number, which is 37. Don't think about which one's more because of a positive negative, just which number by itself is larger, which is a 37. Keep that sign. Negative 35. Alright. Now, next step, we're dividing over here by 3. So, get another color over here. We're now going to multiply by 3. 3 over 1 in this case. Multiply by a 3 on this side. 3's will cancel out. Leave you 7x equals. Now, we've got a positive and a negative. Multiply them together. You're going to keep a negative sign. If you have two different signs, we're going to keep our negative sign. So, we will be left with negative 105. And our final step, we're multiplying by 7 here. Grab one more color. So, the opposite of that is to divide both sides by 7. X equals, we're going to finish this just at the end, a negative 105 and a positive 7. Multiplication or division, we've got opposite signs. We're going to keep the negative. Do the division, you're going to be left with negative 15. Now, if you have to put that into a calculator, so be it. It's, it's one of those things. I do believe you understand, if it really came down to it, that you could do this arithmetic without having to use a calculator. But in this instance, if you need to pull one out, feel free. Alright, so we've worked it all the way down through. Now, let me grab a check step color. Try to keep these colors in line. Check step, the last thing that we have to do, we have to substitute in everywhere we see an X. We're now going to put a negative 15. Our original equation, which I'm going to use this as my original equation. 7, hey, there's an X, so I'm going to substitute in a negative 15 over 3 minus 2 equals 37. Don't let me forget, that is a negative 37. So, 7 times negative 15, negative 105, divided by 3 minus 2 equals negative 37. Do the arithmetic here. What are you left with? You're left with a negative 35 minus 2 equals negative 37. Now, we're subtracting like terms. We're subtracting two terms that have a negative sign to it. So, what do you do in that case? We're going to add the two terms together and keep the sign that both terms have. They both have a negative sign, so we're going to keep the negative. Add them together. 35 plus 2, 37 equals negative 37. Check step worked out. Switch over here to the next layer. Grab my original color here. Let's see. Number 5, solve. We have 10b minus 6b minus 3 equals 9. Put this down. 10b minus 6b minus 3 equals a 9. Now, what can we do before anything gets started? Our first thing to do right here would be to add or subtract our like terms. We have two terms here that have a b attached to it as a variable. So if they both are being multiplied by our b, which that means we have them attached, they're together, we'll be multiplying. What we can do with our actual numbers is we can do the arithmetic between the two. 10 minus 6. 10 minus 6 is 4. Now, we're going to keep our b minus our 3, rewrite, equals 9. Alright, now our next step, we're looking at this. We have solved one of these before. Seeing as how we solved one of these before, I'm going to quickly go through this. We're going to add 3 to both sides, add 3 to both sides, add 3. And I need an equal sign there, I need an equal sign here. We're going to do this. We're going to have 9 plus 3 equals 12, and that is 4b. Grab another color for it. Divide by, erase that. We're going to divide by 4. We don't divide by the b. We're going to leave the b by itself. Divide by 4. b equals, do the arithmetic, 3. Check step real quickly. Everywhere that I see, go ahead and highlight this. Everywhere I see a b in my original, I'm now going to put a 3. If you're multiplying, go ahead and put a parentheses 3. Write it that way. Check step. 10. Hey, there's a b. Parentheses 3. It's a good habit to go ahead and get into it. Minus 6. There's another b. Parentheses 3 minus 3 equals 9. 10 times 3, 30, minus 6 times 3, 18, minus 3 equals 9. Ooh, got a little carried away. Hold on. There we go. Draw this line through here. That's what I was meaning to run off and do. Okay, 30 minus 18. If you need to, come over here. 30 minus 18. Remember how to do the simple math. It's going to leave you with a 12. 12 minus 3 equals 9. 12 minus 3 is 9 equals 9. This is balanced. A 9 equals a 9. This is a true statement. Check step works out. Alright, let me go to that layer. Move to the next layer here. Alright, that was number 5. On to number 6. We're going to be using what we call the distributive property. It gives us 5 parentheses x plus 3 parentheses closed equals a negative 30. Now, this is where we have to be careful. I know a lot of you just want to take this and we want to go, well, that's 5x plus 3. That is incorrect. Let me grab a, no. What we're going to have to do is we're going to have to multiply this 5 times the first thing in our parentheses, times the second thing, times the third thing. However many things we have in this parentheses, we're going to have to multiply it. In this case, we have two different objects. We have an x and we have a positive 3. 5 times an x. Go ahead and draw this line for us. 5 times an x, 5x. 5 times positive 3 plus 15 equals negative 30. First step done. Now, we are adding 15. Opposite step. We're back to our original thing. I'm going to go through this a little bit quicker. We've seen this before. 5x left over here. We've got an equal sign. Do our math over here. Two things. They've got like signs. So it means we're going to add them. Keep the sign. You're going to keep a negative. Add those two together. Get yourself 45. Divide by 5. Divide by 5x equals different signs. That means we're going to keep a negative. 45 divided by 5 is 9. Negative 9. Over here, grab a color real quick for some check steps. 5. Parentheses. There's an x. So I'm going to substitute a negative 9 plus 3. Negative 30. Draw my line real quickly. We're going to go ahead and do order of operations. We're going to do what's in our parentheses first. 5, negative 9 plus 3, negative 6, 30. Multiply these two together, get you negative 30 equals negative 30. Check step works out. All right. Let's look at the next set of problems. We have a little bit, another added step. Let's put it that way. It's a little bit more complicated. 5x minus 21 equals negative 2x plus, get that plus sign looking all right, 28. All right, now, draw my line. Let's look. What do you notice right off the bat? We've got a variable on one side and a variable on the other side. We have to get those both to one side. Now, in order to do that, whenever we take this, we've got a negative 2x. We're subtracting 2x. So instead of subtracting 2x, well, let's add 2x from this side. Now, I think y'all are at the level we should be able to, well, we're going to get the x's on this side. It's always been a good habit of mine, and we're going to keep the x's on the left, and we're going to put everything else on the right. So here, we're going to move this to the right side. We're subtracting 21. The opposite of that is add 21 to both sides. What you do to one side, you have to do to the other. Plus 2x gets you a 7x equals 28 plus 29, 49. Divide both sides by 7. X equals 7. Run through your check steps real quickly. See if that's what you get. Five times 7 minus 21 equals negative 2 times 7 plus 28. Forget the parentheses. Do the math. 35 minus 21 equals negative 14 plus 28. 14 equals 14. There's the line. Balanced equation. All right, I know we've got a little bit left to do here. I know we have 8 through 11. We're going to go ahead and skip those. We're going to forget about 8 through 11. Instead, I want us to go back to problem 1. Now, what we're going to look at in this problem 1 is, I understand a lot of you can do, I'll give you x plus 5 equals 21. That's no big deal to most of you in the class. Now, the biggest thing, and here's what you're going to be asked to do later on. You're going to have to pull these from a word problem, a real world situation. You're going to have to pull the variables, pull the numbers out, put them in the correct order, and then you're going to have to in turn turn around and use the steps that we used in order to solve. So what I'm going to do right now is I'm going to go back and go problem 1, which I'm going to write up here, x plus 5 equals 21. And I'm going to write a word problem that coincides with this. And it's a fictional word problem. It's just coming up off the top of my head. We're going to go with Jim here. We've got Jim. And good old Jim, he has a bag of fuzzy donuts. Now, whenever you say fuzzy donuts, no, I don't mean the molded, nasty donuts. I refer to fuzzy donuts as those white powdered donuts. They got a white fuzz all the way over them, and they get all over the place. That's what I'm going to call a fuzzy donut, not molded, but the white powder. So Jim has a bag of fuzzy donuts. 5 of Jim's friends each give him 1 donut. They themselves, they went and they bought their own donuts, and they all 5 of them give him 1 extra donut. Now, in the end, Jim has 21 donuts. After his 5 friends each give him 1, he adds to his bag. Now he has 21. Now, how many donuts did good old Jim have to begin with? There is the question. We have a, granted, not too big of a real world life-changing problem, one that you'd probably even think about, but it is. It's a word problem, real world problem. Jim has a bag of fuzzy donuts. 5 of Jim's friends each give him 1 donut. In the end, Jim has 21 donuts. How many donuts did Jim have to begin with? This is where we're going to pull it out. He has a bag of fuzzy donuts. Now, he doesn't know how many he has to begin with, so this bag, that's what we don't know. That's our X. This is our bag of donuts that we start out with. Now we know that he has 5 friends that each give him 1 donut, so he gets 5 more donuts. Now it asks how many donuts did he have to begin with? He ended with 21. So his total, he ended up with 21 donuts. Here it is. Here is our equation. Very simple, very basic. X plus 5 equals 21. Do the math like we did before. You're going to find out Jim started out with 16 donuts. Now, let's go ahead and erase this. Start with another one. Now that was very simple, very basic. Let's move up and let's look a little bit deeper at another problem. I'm going to just jump real quickly to problem 6. Now I'm going to tweak problem 6. I'm going to change a little bit of problem 6, and then we're actually going to work through it. We're going to see if it ended up the same. I'm going to take 6. I'm going to take a problem just like 6. I'm going to take it and I'm going to change it just a little bit. 5x plus 3. And instead of a negative 30 here, I'm going to say it has 30. The reason is, problem in my mind is going to need We're going to deal in terms of dollars, and dollars you cannot have negative money. You can only have positive money, so I'm going to leave this positive 30. Now, you go in and you're going to buy, let's say, you are purchasing five. Let's see, the rubber bands for your wrist. So rubber wristbands. I know they've probably already got another name for them, but that's what we're going to say. You're going to purchase 5 rubber wristbands, and you're also going to get, they offer this special solution, and you put this solution on it, and it's going to help it last and extend the life of it for another year. Now, we know this solution costs $3. You're going to purchase 5 rubber wristbands with a solution on each band that costs $3. Now, your total, change that there, your total price was $30. Now, you want to know how much was each wristband. Now, there we go. We've got our problem. We want to know how much each wristband was. Each wristband, over here, grab me a color here. I'll call this our wristband. The price of that, the price of each of these is going to be our X. We do not know that, but we know we've got 5. 5, and we're going to say that's going to be times the cost of our wristband plus $3, because each band has its own solution that costs $3. So the cost of the band plus $3 per band, we're getting 5 of them, and we know that equals to $30. That comes back up, loop out and around. There's our original. Now let's just go ahead and let's work through this to see if it's going to give us the same thing. Go ahead in your mind, think, is this going to give us the same? We've got a negative 30 in our original number 6 problem. Here, we've got a positive 30. Is it going to give you the same answer, or what's going to be different? And why? Well, I'm going to draw my line, and I'm going to go ahead and I'm going to quickly come through here, and I'm going to solve this. We're going to have a 5x plus 15 equals 30. Subtract 15, subtract 15. 5x is equal to 15 divided by 5 divided by 5. X equals 3. Let's put this back in. Let's do a quick check. Now this is different than what we had before, but it's still the same type problem. Let's see if this works out. We've got 5. Hold on, let me get my check step color here. Missed it. 5. All right, I've come to an X, so 3 plus 3 equals 30. 5 times 6 equals 30. Draw my line down here. 5 times 6, 30 equals 30. So, if you were correct this negative sign, it completely changed everything. One, the sign has changed and the number has changed. But what ended up happening? If you go back and look at our check steps, this is one good reason why you do the check steps. In our number 6, we have a negative 9 here. Negative 9 plus 3 is going to give you a negative 6. 5 times negative 6 is a negative 30. This instance, we want a positive 30, so we've got to have a positive 6 here. What's going to get you the positive 6 in this location? A 3 plus a 3, another outside way of looking at it. That checks out. But what you need to take out of this is here is a demonstrated problem. We're going to use the distributive property. And here's a real world type example of such.